We are ready for the last video. I hope it's going to be the last, but I might come back to these. So I yesterday after tweeting a little bit more about these, Craig confirmed that these pieces here, the QFT and then these control plus A, it's just for state preparation, right? So the idea being that I should have a I should just bookmark these. And just work. So, yeah. So the idea being that if you, so in just this, it could be anything else, right? It doesn't have to be a QFT. I think that's just the easiest way to do these, or the fastest way to do these. But the idea is that what you're creating is you're creating an EPR, you're creating an EPR state, right? Like a state where it's basically entangled in these way where all the diagonal elements here are the only ones that have amplitude, right? So this has got like these circuit has got, my guess is, right, some interference patterns that make all these disappear, right? I mean, if you think about a simpler pattern, you could just as well, you know, I mean, what is considered the PR state? Is it just any diagonal type? So I think that those are also EPR states, right? I think so. So you could as well just just do something like these, right? Yeah, I mean, basically, it's just it's just trickier to build. It's like it just takes more drags and drags and drops, I guess. Essentially, what this does is it takes these as an input and it adds, it uses the addition gate, which essentially what it does is what it just did. So it's just a bunch of control knots, I guess, right? So it is just it's just easier. So, but the principle is that if you operate on, that's the way Craig phrased it. If you operate on half of an EPR state, and you can uncompute what you're building with a known inverse, right? Let's say you're building a control S, right? And you know that the inverse is the control S to the power of -1, and then you basically kind of take these, that is obviously a -A, then you should be able to turn the qubits off. Like if you are able to do this means that your control S construction, or let's mention that's what we're testing, right? That's what we're trying to build. At the composition of the control S, right? For example, we're trying to do like check whether these works, right? So two control T's. We know the inverse. So if you can turn this off, this construction is going to work for all possible cases. That is really powerful. And my guess here is that the reason this is this way, and I don't want to do a formal proof of these, but I just wanted to kind of I wouldn't even know where to start, I think, but I just want to kind of intuitively take a look at these, is that you're operating on, so this initial state, right, that you're creating kind of exhibits a bit of everything that you would find in general. So you'd find like interference, you'd find entanglement, and you would find also your superposition, and just because what you would usually do is, you know does it work for a normal state, does it work for, I don't know, like a state that's superposition. So you kind of test that, right? Like you would usually test that sequentially. um, but hey, that seems to be like a generic way to test that this is, you know that you're not missing any, phase kickbacks or anything, any of these things. So, and I wanted to take a look at these basically and try to understand kind of in the context of these, in the context of the, trying to build a control, this control plus one, uh, this way with swaps, with control swaps. See if see why this is true, and like maybe not why this is true, right? But for example, one of the things that Craig mentioned is that if you don't have these register into an eigenvalue uh, of the of the gate you're trying to control, right? Then, um, of course, your control register becomes entangled. Your control qubit becomes entangled with these, right? Because then you have this kind of duality where is it going to be applied or is it not going to be applied? Because then it makes a difference, right? That this poisons these, and that this poisons this register, and that it won't always work weird, or it won't always work when you're trying to doing, like when you're gonna have a case of interference with the control qubit. Now I was wondering how these setup account for these. So if I remove these, right, we see that indeed you're not like, we haven't really like been able to turn this off completely. We have these two qubits in here, right, which still have chances of measuring on. Now I'm curious whether this is something that we're detecting because of this entanglement or not. What happens if I remove these? So we're still detecting it. So this is not necessarily accounting for these. Hmm. In other words, that doesn't seem to be the reason. If I take this back, we're turning this off. Hmm. Okay, so so what is it that we're, I don't know if I explain myself correctly, but like I'm trying to find what is it that you would catch for these that we're not catching here. That is obviously this. Obviously, what you can, okay, so what you're definitely catching here, it's not catching, but like you see that any operation in here actually just messes up with everything. Right? So what this is kind of telling us is that, if your circuit is bigger, obviously, and you're just doing these, right? You're, yeah, okay, I get it. So what this is just supposed to show is that, I guess it's not supposed to test against anything concretely, but it's just telling you that you can see the effects of, how your operation will get spoiled if something else happens in another wire that is entangled, like, you know, with your top three um, wires that you care about, right? Yeah, for example, in this case, nothing would happen in the last wire. No, yeah, here, yeah. Yeah, there you go. So, exactly. So here you have, like, it's not working anymore because they're not off. So this is supposed to be, it's like that intrinsically doesn't help you test against anything, right? But it's I don't know how to put it. It feels like it's just it's like a general test bed for these, right? Because you could just say, maybe I'll have another idea. Maybe I'll just, you know, swap these again somewhere else, and you do something like these, right? I don't know. That still works. It's like I kind of, yeah, I get what this is trying to explain, but I don't think this is supposed to catch any mistakes in your construction. This is just to show that this is just to show that because okay, but this is not telling you anything about the poisoning of these. You know what I mean? The poisoning of this register. That's what I kind of don't see in here. Which would be cool to see. Like I get it, right? Like you need to be like if you're building a control plus one, this needs to be uncomputed. And it's obvious that if you don't have these things in here, then this is not doing what a control plus one should do, right? It's just leaving some of these things, um, yeah, basically not properly working. But it's not. Mm, mm. So I mean, I don't know. It kind of makes sense. Okay, to an extent, okay, let's try one thing. Yeah, exactly. There you go. To an extent, okay. I think I understand. So this is actually supposed to show, it's really supposed to catch mistakes in the construction, right? Where if you would be now saying, I'm gonna negate these and negate it here, you know, like you're kind of computing doing these and then I'm computing it and blah blah blah, or like, but you can see that certain gates have effects on this bottom register, and that's what you want to avoid. That's what this is supposed to catch. Okay, I like it. It's just that that particular example didn't show that, but these, yeah. So this is basically, you know, I like it. So you're operating on half of an EPR because you want to check whether what you're doing doesn't have any effect across entanglement. So it doesn't have something that spoils another part of your system in case, you know, they were prior to your gate, to your construction entangled. So there are certain gates in here that will just, you know, create effects down here. And so you want to be able to catch these things. That's actually really cool. I mean, Could you use that more generally for? It's like, hey, when you're building portions of, of a circuit or working on a decomposition, uh, that that is definitely something that is helpful, because you can see these effects across entanglement. You can make sure that you're really able to uncompute these, and so you need to know you need to know a well-known inverse, right? I wonder if you just know how to uncompute these. If you just know how to uncompute these, whatever you're building. Yeah, no, because then it cannot be, the thing is you cannot use the same, right? Like you would just use the same construction, but like reverse it. But then, yeah, you would obviously turn the qubits off. You got to use something that is different, that it's like an inverse that you know. So maybe that's not so generally useful, but it's nice to see the that uh, that that this is useful, and uh, and that this is a measure of, is this doing exactly what I wanted to do, right? Because if you're missing the phase, if you're missing something like the phase, right, like you will need to actually now figure out, okay, so what's wrong here, right? Well, that would be actually complicated to figure out, I guess. Right? Ooh. That would be complicated to figure out. How would you figure this out, though? I don't know how you figure this out. Other than by trial and error. It's funny because it literally doesn't matter where you put these in your. Hmm. It's funny that it pops up here, but it's literally. It's literally the effect of. So you know what? I think I will use these as an example for when I build the interference-based uh, simulator, where you can kind of see how not interference entanglement based, where you can see how the entanglement is built up, and then you can see things like the phase kickbacks better than in here, because these is literally. It's like I can't think of a systematic way where you would figure out, like, hey, I got these here. How do I know that what I need to have is a phase correction up here? Right. Because I guess by trial and error you'd figure it out, but like I'm not so sure. I'm not so sure how I would know that I need to fix these. This would be okay, but this is the puzzle. This is definitely going to be the puzzle. So what I'm gonna do for the puzzle is I'm gonna do so let me just create the puzzle here quickly. So I'll definitely do that. I'm thinking what is better to do in terms of design, whether we want to have it like these and keep that as a target register, probably. And then we want to have a, so what I will do is I might actually just hide these and like, so, you know, just call these U and then call these, just because it will make the exercise a bit more generic, U inverse, right? And so what we're trying to do at the end is you're trying to do the control of the U inverse, right? And so what you're doing here is you're doing the, I'm thinking whether to include the puzzle, the swap sandwich or not. Exactly. So we have this U and this U inverse. And so the idea is, you know, they'll have to find, so that the gist of the puzzle is they'll have to find a, I like to put the separators in here as well. So they'll have to find how to turn the qubits off, right? So the idea would be if I just let me double check, if I do these and if I do these and if I do these, it's not working. Why isn't it working? Because this is a minus A. That's why you should always test your puzzles first. Cool. Cool, that works. Okay, so this is the puzzle, really. So you'll need to figure out two things. They need to figure out these, and they need to figure out the phase correction. Oh, and then, oh, yeah. And maybe we'll just kind of like also get rid of these. Yeah, I like that. Because this is going to create some stuff in here, right? If I know it's stupid, but if I do it like these, it's going to make it... Yeah, exactly. Turn the qubits off. So that's going to be the puzzle. Cool. I'll publish that. Yeah, anyway. That is really, really helpful. It's going to need a bit of context in terms of writing what the challenge here is and stuff like that. But yeah, cool stuff. Thanks a lot, Craig, for all the insights. This has been beautiful, and this has been super helpful for me. As in, like, yeah, it kind of makes sense. I mean, having this idea of testing on an EPR pair, because you're testing for everything. You're testing for entanglement. You're testing for interference. You're testing for... Still, as I said, I'm not so sure how you would test the poisoning here. I get it has to be off because otherwise you're not strictly doing a control node, it's doing a control plus one, it's doing a control plus one and something else. And if you then want to do some interference, I mean, what if I would do... it wouldn't work as expected. Like, what if I would... I don't know. It's like this is entangled with these, but it's not entangled with the control. So the problem is not really with the control, right? Because I think that's what Craig is saying. is that? There's a phase kickback. Would you want to keep? No, not these. Since but later interference involving the control won't work right. Also poisons your alternate register state, so it can't be reused. Because I think what I'm seeing here is I'm seeing entanglement just between the two here, right? Like if I move this one here and I take a look at, oh, huh? Okay. No, totally off, 100%. These two seem to be entangled. Okay, now I'm a bit confused. Maybe these are not fully... I always thought you could just take a look at the block spheres and see such tangled effects there. But obviously you cannot. So I cannot just easily say what's entangled with what. Interesting. Some interference effects involving the control won't work well. But so far this seems to be because of the entanglement down here, but not because of, you know what I mean? But not because of these two guys. Because if I keep these like that, I still see the effects that I don't want to down there. Right. So I'm not entirely sure about these. I get it that it's not doing what it's supposed to do, but I'm not entirely sure about these interference effects. It's something maybe to take a look at, to come back at once I have the entanglement simulator, because then I can maybe take a look at it from a different perspective. Yeah, I hope I will remember. Definitely. Cool. That's a good one. That's good. And we got a new puzzle publishing soon. Awesome.